Hey, hello there. It's Mr. Casey from Pendrahowell School in Swansea. We're going to be doing a session for this autumn's Carl and Cymru sessions on solving simultaneous equations. I'm just going to share my screen, so hopefully you can see the lesson as well. So I've just shared that, and hopefully you can see that, and you can see obviously me speaking. Okay, so we're going to talk through the session now, and we'll go through a few things. So first of all, this is the second session I've done. This is solving simultaneous equations. And I've previously done a session on solving linear equations. And then Mrs. Dixon, also of Pendrahowell School, is going to do 2 sessions on percentages. And then we're going to do a summary lesson later on in October. Okay, so let's have a look at the scheme of work. So the GCSE syllabus. So this is the WJC, so the Welsh syllabus. And you will notice that solving simultaneous equations does appear on mathematics, but doesn't appear on numeracy. So if you're entering the numeracy exam in November, it's probably not worth watching this video for numeracy, but certainly if you're doing your maths exam in November or possibly the following summer, this is definitely something that is worthwhile watching. Okay, so we're just going to do a little bit of practice at solving linear equations. Some of the skills that are involved with solving linear equations will come up in simultaneous equations. So I covered this in my last session. So if you can just pause the video, have a go at these 4, then I'll jump back in and we'll look at the answers. Okay, so let's take a look. So first one is what we kind of call a 2-step equation. So we've got a -4 here. So I'm going to add on 4 both sides, add 4, add 4. That gives me 9y is equal to 27. And then the coefficient is 9. So I'm going to divide by 9, and then the value of y is 3. Now I have been through that fairly quickly. If that is completely unfamiliar to you, or you don't understand how that's done, it's definitely worth watching my first video on solving linear equations. Okay, this one, we have got a 4, and then we've got a 4a in brackets. So when there's brackets in the equation, generally you want to kind of expand those brackets and get rid of them. So I'm going to do 4 times 4a, which is 16a, 4 times -7, which is -28, and all of that is equal to a negative or -92. Now I'm going to add on 28 this side, add on 28 this side, and that's going to get rid of the -28. So the 16a is still there. -92 add 28 is -64. Again, I divide by the coefficient in the end, so I divide by 16, both sides of the equation, and that gives me a value of a being worth -4, because of course it's -64 divided by 16. And the last one, I'm going to expand that to get 8m, oops, excuse me, so 8m, pen's going a bit crazy, plus 6 is equal to 24m minus 2. So I haven't really changed anything there. All I've done is expand the brackets, and I've wrote it in a different way. Now, if you notice, there's 24 m's this side and there's 8 this side. So I want to get all the m's on the sort of right-hand side. So this being the left, this being the right. So I'm going to take away 8m from both sides. Take away 8m, take away 8m, and I'm left with a 6 there. 24 take away 8 gives me 16m minus 2. So this -2 I want to get rid of now, so I'm going to add on 2 this side, add 2 this side. So I've got 8 there equals 16m, and I haven't got a lot of space left. But if I divide by 16 now at the end, divide by 16 gives me a value of m. I can put m over this side now if I want. So let's have a quick look. Yeah, so it's going to be 8 divided by 16. So the answer to this is actually a half. Okay, so what I've done is 8 divided by 16, which is 0.5 or a half, and then m is on its own. Okay, so let's take a look at what we're going to cover today. So we're going to do some revision of linear equations. We've just done that. We're going to solve simultaneous equations with the same coefficients. We're going to solve simultaneous equations with different coefficients and do some sort of problem solving and then some GCSE questions if we've got time at the end. Okay, so on this equation, we've got 2x plus 8 equals 15. And that's very similar to the sort of equation that we had earlier. That's a linear equation. Okay, it's got one unknown, so it's got this x. We're trying to find the value of x. We're not going to do it, but this is the sort of thing we come across before. That's just one unknown. Okay, but on the other side, we've got this equation. So it's 4x plus 5y equals 15. Now, there's two variables. There's an x and a y. Now, we can have a bit of a guess. We could kind of think, what could x be? What could y be? But it would just be a guess. Okay, so there's no real way of working these out. So what they do is they give you two. So two equations, both with x's and both with y's. What's important to understand is the value of x is the same in both. The value of y is the same in both. And what we kind of do is work together and we solve them simultaneously. That's why they're called simultaneous equations. And we find x and y kind of at the same time. Okay, so that's how the questions work. So let's do an example. So this first example is going to involve a little bit of adding. You've got 2x minus 3y is equal to 0, and you've got 4x plus 3y is equal to 18. Now, what's important to understand is we're looking at the coefficients of y or the coefficients of x, and we want them to be the same. So I'm looking for the numbers in front of x being the same, which they're not. One's a 2, one's a 4. But the numbers in front of y, they are the same. They're both 3s, which is what I want. So what I'm going to do is I'm going to put a line at the bottom there, straight enough, I guess. Line there. There's my equal sign. Okay. Now I've got a minus and I've got a plus. Okay, so what I'm going to do is I'm going to add these two equations. So I've got 2x and 4x. I'll add those together and that will give me 6x. Okay, and I've got minus 3 plus 3. So I'm adding plus 3 to a minus 3, which gives me 0. So the y's disappeared, and 0 add 18 is just 18. Okay, now I've got 6x equals 18. This is really similar to an equation I had earlier. I'll divide both sides by 6. So divide by 6. And remember, whatever you do both sides. Divide by 6. So that gives you an answer. X is equal to 3. So I've only found one part of the puzzle, really. I found out that x is 3. Okay, so the next thing I need to do is substitute that back into the equation. Now I can choose whatever I want. So I think I'll always write sub in. So substitute in x equals 3. And let's have a quick look. So I'm going to pick this one. Now I normally don't have to, but I normally pick the equation that's got less negatives, and this has got no negatives. So I'm going to substitute that in. So I'm going to write it out: 4x plus 3y equals 18, and I'm going to swap this x for a 3. So instead of doing 4 times 3, I'm just going to write 12. So hopefully you can see that the value of x is 3. So 4 3s are 12 plus 3y equals 18. I want to get rid of this 12, so I'm going to take away 12 from both sides. So I've got 3y is equal to 18, take away 12, which is 6. And then when I divide by 3 at the end, y is equal to 2. Okay, so this is what I've got. I've got my solution for x, which is 3, my solution for y, which is 2, because I substituted in the x is 3 value. And what I could also do at the end is do another bit of substitution to check my answer. Now, we're not going to do this every time because it will take too long, but let's have a look. So I think x is 3. So 2 times 3 is 6. I'm looking at this top equation here. 2 times 6, take away. Y is 2. 3 times 2 is 6. And 6 take away 6 equals 0. So what I've just done confirms by substituting back in that I've got the right answers because it balances and I got the answer that I was expecting. Okay, another example of adding. So this time I'm looking at the coefficients of y. That's a 2, that's a 4, that's no good. But x have both got a coefficient of 1. So remember, we don't write 1x, we just put x. So that's 1x, that's a minus x. The signs are different, so it's going to be an add again. So that x's are gone. Add those together, I get 6y, and add those together, I get 12. Divide by 6 both sides, or you could say 6 times what is 12? The value of y is 2. So I now need to sub in y equals 2. So sub in y equals 2. I'm going to substitute it back in. I can pick any equation I want, really. I don't know, I think I'll pick this top one. So I'm going to put x plus 2y. I'm not going to bother putting 2y now. I think y is 2, so 2 times 2 is 4 equals 7. I've got quite a nice equation to solve now. Just by taking away 4 both sides, it's going to give me an x value of 3. So I've found my x, I've found my y, and if I wanted, I could substitute them back in, just to confirm that's right. Okay, we'll do a couple of examples of subtracting, and then I'll give you a go on some questions before we move on with the trickier questions. So example 3, I got a 5x and a 3x. I'm not going to be getting rid of them because the coefficients are different. That's a 5 and a 3. But the 2y, they both got a coefficient of 2. But this is slightly different because they're both positive. Okay, it's a positive 2 and a positive 2. So I'm going to subtract the equations. So I'm going to do 5x take away 3x, which is 2x. 2 take away 2 is nothing. The y's are gone. The 80 take away 70 is 10. So I got 2 times something is 10. So 10 divided by 2 will get me the answer. The value of x is 5. Now, I got one of the answers, so the process is same now for the previous questions. I'm going to sub in. So sub in x equals 5. And I can choose any equation I want, really. I think I'll choose this top one. So it's 5x, which means 5 times 5. So I'm just going to write that as 25 plus 2y equals 80. I'm going to take away 25 from both sides just to get y on its own eventually. So that becomes 55. Bit of a weird answer this, because I'm going to divide by 2. The value of y is a half of 55, which is 27.5. So that's a bit of an unusual answer, but that does happen sometimes. You will get decimals, you will get negatives. They're not always going to be positive whole numbers. Okay, so there's 2 there for you to try. One's going to be an add, one's going to be a take away. So if you have a go at those 2 questions, and then I'll come back in and we'll go through the answers. Okay, so hopefully you've had a go with them. I haven't got a lot of space in the slide, so my workings are going to be a little bit cramped. So first of all, the signs are different in front of the y terms, and they're the terms I want to eliminate. Remember, I'm not always looking at the signs at the front. It could be the signs at the beginning, but in this case, I know it's going to be an add. So I'm going to do 6x add x. This is going to be 7x. I'm going to add the y terms, they disappear. And 6 add 8 is 14. So that's worked out pretty nicely because I know 14 is a multiple of 7. 7 times what is 14, and that what is the value of x, which of course is 2. So I'm going to sub in that value I just found, sub in x equals 2. I'll do it in the top equation, I think. So I know x is 2, so I'm going to do 6 times 2 is 12. That's a plus, sorry, plus 2y equals 6. My dodgy looking plus is a plus, it looks a little bit like a minus. I'm going to take away 12 from both sides, take away 12, take away 12. That gives me a value of 2y. 6 take away 12 is minus 6. And then I'm going to divide by 2 at the end. So divide by 2 gives me an answer of minus 3 for y. The next one, draw my lines again. So I'm looking at the x's, I'm looking at the y's. So I think it's the x's I need to get rid of now because they've got the same number in front, the same coefficient. It's going to be a takeaway. What I'm going to do is 2x take away 2x, the x's are gone, but you're going to be careful with the negatives here. So you've got minus 3y take away 4. That's going to be minus 7y. Okay, so minus 3 is our start number. We're taking away 4. And I got 5 take away 12. That's also minus 7. So I need to divide both sides by minus 7 now, really. So the answer of y is 1, a positive 1. So minus 7 divided by minus 7 gives you an answer of 1. And then I'm going to sub in the y value now. So y equals 1. I'm going to substitute that into, I can choose any equation I want, really. I think I'll choose this bottom one because there's no negative. So I got 2x plus 4y, and that's 4 times 1. So I'll just write that as 4 equals 12. Take away 4 from both sides. So the value of 2x is equal to 8. And then divide by 2, the value of x is 4. Okay, so what we often get with these questions is the coefficients are different. So if you notice here, we've got 3m and 2n, and we've got 2m and 5n. So it's not just a straightforward case of just, let's just get on with it. Let's just add them or take them away. Okay, so what we need to do is do a little bit of manipulating before we actually start. So what we're going to do is we're going to try and get one of the coefficients the same. And I think what I'm going to try and do is get these m's the same. Okay, so I'm going to get this into a 6m, this into 6m. The reason I've chosen 6 is because 3 goes into 6 and 2 goes into 6. Okay, so just excuse that announcement behind me. Okay, so I'm going to multiply that entire top line by 2. Okay, so I'm not just multiplying. I'm not just multiplying the first bit. I'm multiplying the entire line by 2. Okay, apologies, that's just disappeared. Okay, right. So so I'm going to times that by 2, and that gives me 6m plus 4n equals 40. Okay, so that's my first step. Now, I'm going to times all of that one by 2, and sometimes you can get away with just multiplying 1, but in this case, I think we are going to have to multiply them both. I'm going to multiply all of this one. This pen is playing up a little bit today. It's been a bit impatient. Let's have a look. Okay, I'm going to times all of this second one by 3. So I'm just going to put a little times 3 here. Okay, so that gives me now 6m plus 15n equals 17 times 3, which is 51. Okay, so a little bit of effort at the start, but what I've now got is I've got 6m and 6m, the same coefficients. So I can do a takeaway because they're both positive terms. They're both a positive 6m. Okay, so now I'm gonna take those away. Okay, so bit of a funny one this, because I've got 40 on top and 51 below, 4 on top and 15 below. I can rearrange these. I can swap these over for once. It doesn't matter which one's on top, which one's on the bottom. So I'm just going to imagine this one's on top. So I'm going to do 6 take away 6, that's fine. I'm going to do 15 take away 4. That gives me 11n. And I'm also going to do 51 take away 40. So what's on top doesn't really matter to get 11. 11 times something is 11. So that something is going to be 1. The last step is always the same. I'm going to sub in n equal to 1. Remember, I've got x and y's this time, but you're not always going to have x and y's. I think I'll sub it into, I don't know, the bottom equation. It doesn't matter. So I'm going to put 2m plus 5n, so 5 times 1, which is just 5, equals 17. Take away 5 from both sides. Remember, I'm trying to get m on its own. That gives me 12. Divide by 2. The value of m is 6. And the value of n I found earlier, that's going to be 1. So if you ever try one of those yourself, where you have to change the coefficients, so have a go at that question, and pause the video, please, and then come back in, and then we'll go through it together. Okay, so hopefully you've had a little bit of time to have a go at that. Now, I may start doing the workings for this now, and you may have done it a different way. That doesn't matter. So for example, you may have made the h's the same, so maybe made them both 30h, or you might have made the d's the same, made them both into 15d, because the lowest common multiple of 5 and 3 is 15, so that'll be sensible. I think that's what I'll do, but if you've done it a different way, it doesn't matter. In theory, we should get the same answer. So I'm going to times this first one by 3. Remember, all parts should be multiplied by 3, so 18h minus 15d, and I've now got 38 times 3. I've left myself a lot of space, but that is 114. Okay, this one, I'm going to multiply this by 5. So, bit of a shaky arrow there. So I'm going to times that by 5. That gives me 25h. Take away 15d, and that is equal to 27 times 5, which is 135. Okay, excuse for the messiness, but what I have now got is a minus 15d and a minus 15d. Now, we haven't really come across them with two minuses, but when the signs are the same, it is a takeaway. Okay, now this is a bit going on here because the bigger numbers are on the bottom, but that's okay. I can do 25h take away 18h. That gives me 7h. I can do minus 15 minus 15, which means minus 15 add 15. That means it's gone. The 15s are eliminated. And 135 take away 114, which is 21. Divide both sides by 7. The value of h is 3. So I'm going to sub in h equals 3. I'm going to choose any equation I want really, and you could choose one of the bottom ones. I mean, I wouldn't. I choose one of the top ones. But I'm going to choose this top one here. So 6h, which is 6 times 3, which is 18, minus 5d equals 38. I'm going to take away 18 from both sides. So take away 18 there, take away 18 there. Now be careful now, because this minus 5d is part of the equation. So that minus has got to stay. That minus 5d equal to 20. Divide both sides by minus 5, divide by minus 5, and then the answer is going to be a negative 4, so minus 4. So just be careful with the negatives there. I think there's a chance to miss that minus out, and then you'd have the answer wrong. Okay, so we'll do a problem solving example. Let's have a look at the question. So it says the rectangle has a perimeter of 30 centimeters and the triangle has a perimeter of 21 centimeters. Okay. Form and solve the equations and calculate the value of x and y. So these are quite common type questions. We know the perimeter is the distance all the way around. So let's try and sort of form an equation for each shape. So I know this side of the rectangle is 3x. So if that's the case, this must be 3x as well. And that's y. That must be y, because it's a rectangle. The opposite sides of equal length. This one, well, we're okay with that. They're all labeled. Now, I'm just going to sort of do a few scribbles. I know that's 30 centimeters perimeter. It says that in the question. That's 21 centimeters. Okay. Right. So I'm going to make an equation for this rectangle. So what have I got? I have got 3x there and 3x there. So in total, I've got 6x plus there's 2y's. So I'll put 2y, and that is equal to 30. So that's my first of my simultaneous equations. And for the triangle, I've got x, 3x, and 2x. So that makes 6x as well. That's a good sign. But I've got minus y. There's only one minus y there, and that's equal to 21. Okay, so these are my two equations. So now I'm looking, there's a 6x and a 6x. So I can probably take them away. So I'm going to write the rectangle equation out on top. So 6x plus 2y equals 30. And then 6x minus y equals 21. So I'm going to subtract those two equations. So 6x take away 6x. I'll put my lines in first, so it's a little bit neater. They're going to be the straightest lines I've drawn so far, I think. So 6x take away 6x is gone. And then I've got 2y minus 1y. So if I'm minusing a minus, I'm kind of adding. So 3y is the answer I get. And then 30 take away 21 is 9. That gives me an answer of y. 3 times something is 9. So that's got to be 3. So I'm going to substitute in y equals 3. Again, into any equation. So I've made two equations here. I'll probably choose the top one because it hasn't got any negatives. You're more likely to make a mistake with negatives. So 2 times 3 is 6, isn't it? So I'm going to put that as 6. And then that is equal to 30. Okay. So 6x. I'm going to take away 6 from there and take away 6 from there. So 6x is now equal to 24. And then divide by 6 both sides, gives me a value of 4. And in most cases, if you do sort of a shape question like this, you're going to have positive values. Okay, so it's unlikely to have a negative value of x. I suppose it is possible, but you know, it's not really possible. No, you're going to have positive values. Okay, so y is equal to 3 and x is equal to 4. Okay, so some GCSE questions. Now, some of these questions are pretty wordy. Okay, there's a lot going on with these questions. So what I think I'll do is I'll give you a bit of time to sort of look through the question, try and pause the video, try and sort of work out what you need to do, and then I'll come back in and I'll work through the question with you. So probably worth pausing now, having a look at the question, and then coming back in. Okay, so let's take a look. So the Davis family went out to buy some garden furniture. Their local garden centre stocks the particular brand they would like. The price of one garden bench and 4 chairs is £310, so obviously pretty good quality stuff. The price of 2 garden benches and 3 chairs is £345. Okay, so Davis family have £450 available to spend. Do they have enough to buy 2 garden benches and 5 chairs? You must surely work in. Okay, so the question's kind of asking, do they have enough money? That's kind of what the question's asking. But there's certainly some implied tasks in there. And that implied task is you have to work out how much a bench cost, how much a chair cost. That's what we kind of have to do. Now, they haven't given you any X and Y or any variables, so we can kind of use our own letters if you want. I think it's logical to use B and C for bench and chair. I think that kind of makes sense, okay? Right, so let's have a look. Right, so let's start off by doing some equations. So the price of one garden bench, I'm going to put that as 1B. I know we can just write B, but 1B plus 4 chairs, so 4C equals 310. Okay. And then it says the price of 2 garden benches. So I'm going to write that as 2B. And the price of 3 chairs, so 3C, this time is £345. So that's kind of my 2 simultaneous equations. Now, I'm not a big fan of these two because they haven't got the same coefficients. So the number in front of B is 1, the number in front of B is 2. So that's not ideal, okay? But because one of them is 2, one of them is 1, I only really need to multiply this one. So I only really need to times that by 2. So I'm going to times that one by 2. So that's going to be 2B plus 8C, and 310 times 2 is 620. Okay, so that's okay. And then the other equation, I can leave that as it is. So I'm just going to write that out again. Or to be honest, I could probably just leave it there. So that 2B plus 3C, that could stay there. Or I'll write it out again, I think, for the fullness of the note. So I'm going to write times 1. That's logical, isn't it? Staying the same, so we're kind of timesing by 1. So 2B plus 3C equals 3, 4, 5. And I've just written over my number 5 there. You may have noticed that 5 there from the mark scheme, which means, of course, it's a 5-mark question. So quite a lot of marks that we had for one question. So I'm going to take away now. So 2B, take away 2B, they're gone. The B's are eliminated. 8C, take away 3C is 5C. And 620, take away 345 is 275. I'll divide by 5 both sides. So the value of C is £55. That tells me the chair is worth £55. I now need to sub in to find the cost of the bench. So I haven't got a lot of time. Sorry, I meant I haven't got a lot of space rather. So I'm going to sub in C equals 55. I think I'll choose maybe that that top equation. So this one here. So I've got 1B. So I'll do 4 times 55 now. Now 4 times 55 is 220, and that's equal to 310. And because there's just 1B there, I can take 220 from both sides. I can do minus 220, minus 220, and that will give me an answer of B is equal to 90. So my bench is worth £90, my chair is worth 55. Now at this stage, I'm fairly confident I've nearly finished the question, but it says they have enough money to buy 2 garden benches and 5 chairs. And of course, they've got £450 to spend. So let's have a look. So 2 benches. So I'm going to do 2 times 90. And I'm also going to do 5 times 55. So add that together and it gives me an answer of £455. If you leave it at that, you're quite possibly going to lose a mark because you're not answering the question. They have enough money, and the answer pretty much is no. They don't have enough money because £455 is greater than £450, which of course is the budget that they've got available. So quite a lot of work, but the simultaneous equations, once they're formed, are fairly easy to solve. We then substitute in as we have done before, and then you just do this little final stage of seeing if they've got enough money to buy the furniture they need for their garden. Okay, so this is question 2. So let's have a quick look at this. Okay, so have a read yourself, and then we'll pause the video. I'll come back in and I'll run through the question. Okay, so hopefully you've had a chance to do that. So let's read through the question together. So Poppy buys 3 kilograms of cherries and 5 kilograms of raspberries. So I'm thinking, C and R for my variables straight away. Harry buys 4 kilograms of cherries and 7 kilograms of raspberries. Poppy spends £66.10. Harry spends £91. Use an algebraic method to calculate the total cost of 10 kilograms of cherries and 1 kilogram of raspberries. You must surely work in. So we have to find the value of 1 kilogram of each. Now, I've no idea why they need to buy so much fruit. 7 kilograms of raspberries is a great deal of stuff, but we'll just go with the question and see where it takes us. So let's look at Poppy first. So Poppy is buying 3 kilograms of cherries and 5 kilograms of raspberries, and that is costing her £66.10. I could put 66.1, but that's fine. Harry buys 4 kilograms of cherries and 7 kilograms of raspberries, and that's costing him £91. Now, I can't take these away or add them. I mean, everything's positive, so it is going to be a takeaway in a moment, but that's 3C, that's 5, the coefficients are different, so that's not ideal. So let's make the coefficients the same. Now, for me, I want to keep the numbers as small as possible because these numbers are going to get pretty big. So I'm going to get the number in front of C the same. So I'm going to times all of this one by 4. And then I'm going to times all of the bottom one by 3, but we'll do that in a moment. So that becomes 12C plus 20R, and 66 times 4, I worked this out on a bit of paper earlier, is 264.4. So 264.4 in money, of course, that would be £264.40. This one, I'm going to times that by 3. So that becomes 12C plus 21R, and then we're doing 91 times 3, which is 273. Now I'm at that stage where I can take them away. So I can kind of do it in reverse here. I'm going to do the bottom, take away the top. That's the easiest way to do it. So 21R, take away 20R is just 1R. I can write that as R. And then 273, take away £264.40 is going to be £8.60. Okay. Now, really haven't got much space to solve the rest of this. I am going to try and sub in. So I'm going to squeeze my little sub in at the side here. Sub in R equals £8.60. So I'm going to take the 4C equation. I think this one here, the £91 equation. So I'm going to do 4C plus 7 times 860, which is £60 and 20. My pen's having a funny 5 minutes. And all of that is equal to 91. I'm going to take away that £60.20 from both sides. This should be a bit clearer. So 4C is now equal to £30.80. And I divide by 4. The value of C is £7.70. Okay. So I got the value of R now. So raspberries are £8.60 a kilo. Cherries are £7.70 a kilo. And what I'm now going to do is just answer that sort of last question. So find the total cost of 10 kilograms of cherries. So it's going to be 10 multiplied by the cherries, which is £7.70. I'm adding on 1. So 1 multiplied by 860. So that's obviously just going to be £8.60. Work those two out, and then we're going to have an answer of £85.60. That is a lot of money to spend on fruit. Okay, so let's have a look at one more GCSE question. Okay, so let's take a look. Okay, so there's a lot going on here, and it's also an OCW question. Okay, so we have sort of spoken about OCW marks in other videos. So for the OCW marks, you're going to get 2 marks for your organization, your communication, your accuracy of writing. They look for things like labels at different stages. They also look for things like have you used the correct units. So there's various things that you should discuss with your teacher, how you're going to get your OCW marks. Of course, those OCW marks, those 2 marks, could be the difference of a grade from a B to a C, for example. Okay, so you try and get those marks. So let's have a look at the question. So each side of the square is of length 2x plus 3y centimeters. That's every side of the square, okay? And then each side of the regular octagon, so what's important is it's a regular octagon, which means all the sides are the same length, is x plus 2y centimeters. The perimeter of the octagon is 72, and then the perimeter of the square is 62, okay? Right, so let's get some equations going. So let's do the square first. So if that's 2x, I'm going to times that by 4. So that's going to be 8x, because of course there's a 2x on every side, plus 12y, and that is going to be equal to 62. So that's going to be the perimeter of the square. For the octagon, I'm going to times x by 8 this time. So it's going to be 8x plus 16y, and that is equal to 72. Okay, so they're the 2 equations I'm kind of working with. Now, this is quite a nice question because they're both 8x's. So if I'm going to take them away, I think what I'll probably do is put 8x plus 16y equals 72 on top. And then I'll put the 8x minus, oh, I missed the y out on this one, look, 16y minus 12y equals 62. Okay, so I'm going to take them away now. I'm going to take away 8x, take away 8x. Yeah, 8x to 8x is 0, okay, because they're both positives. And I'm then going to do 16 plus minus 12. Now, because it's 16 plus minus 12, that pretty much means 16 take away 12. So that's going to be 4y, and then 72 take away 62 is 10. Okay, so when I divide by 4, it gives me a value of y to be 2.5. All I've now got to do is sub in. So sub in y equals 2.5, and I can use any equation I want, the top one, the bottom one. I think I'll probably use, I'll use the bottom one. I'll use this one here. So a quick look. Oh, I think I made a mistake there. Actually, sorry, that is a plus 12y. But actually, the answer is correct. Okay, so 16 take away 12. Yeah, so apologies, I thought that was a minus earlier. I think I may have mentioned it was a minus, but yeah, that stays as a plus, and it doesn't affect the question. Everything else is right. So I'm going to substitute that 2.5 into the bottom equation. So I'm going to do 8x plus, now 12 times 2.5 is 30. So I'm just going to put 30 there, equals 62. I'm going to take away 30 from both sides. So the value of 8x is going to be 62 take away 30, which is 32. And then divide by 8 both sides. The value of x is 4. Yeah, of course, 4. 32 divided by 8 is 4. Now, I wouldn't be content with that. I'd have to go back to the question to make sure that what I've done is right. So, you know, remember the last couple of questions, there was an additional stage. Just make sure this question is asking us and we've answered it, you know, fully. Use an algebraic method to find the value of x and the value of y. That's exactly what I've done. Y is 2.5, x is 4. I've answered the question, okay? But be careful, don't leave it just with that final solution. Always go back, double check the question, make sure you proofread it, and make sure that you've actually answered what the question is asking. Okay, so we're going to skip, well, that's actually it. I was going to say I thought there was another question, but there isn't. But we are going to discuss what we've done. So we've done a bit of revision of linear equations. That was right at the start. We've solved simultaneous equations with the same coefficients. Remember, they're the ones you don't need to multiply. And then we did some simultaneous equations where you have to multiply one or maybe both of the equations. Then we did some problem solving, and then we looked at some actual GCSE questions. Now, not a bad topic, okay, fairly straightforward. As long as you get those equations right at the beginning, I think you'll be okay. Right, so let's have a look at a little plenary just to finish off. So we've looked at a few sort of words as we've gone on. There's some key words there on the right. Some of them, you know, aren't applicable to this plenary, but I thought I'd put a few extras in. And just sort of have a look. and this should sort of sum up things quite nicely. So you haven't got to write down the full question, but just try and work out what word goes in each line. Pause the video, have a go, and then we'll come back in and we'll just sum up at the end. Okay, so let's take a look. So the first one, checking the blank are the same for one variable before adding and subtracting the equation. So we're checking for the coefficients. Oops, I apologize, that's just clicked off. So we're checking for the coefficients. Okay, so the first answer you should have written, or you should have sort of worked out, is coefficients. Because remember, we're looking for, we want 2x and 2x, or 3y and 3y. That's what we're after. Okay, if the signs are the same, so looking at the coefficients, if the signs are the same, we subtract. So we subtract the two equations to get rid of one of the variables. And if the signs are different, we add. So if I've got a minus 7x and a plus 7x, I'm going to be adding the two equations. Once you've found one variable, you substitute. Remember, I wrote sub in. So sub in is short for substitute. Substitute to find the second variable. And then to check the answers are correct, you could substitute into the original equations. We did this right at the beginning, but I didn't do it for every question because it would have taken too long. So a bit of a trick there at the end. Substitute was used twice. Okay, so hopefully that's been useful. Like I mentioned, it's probably worth watching the video on linear equations as well. But obviously, I probably watched that one first. So this one is probably to be watched after. The next session is going to be with Mrs. Dixon on percentages, and then we're going to do a summary of the algebra, the equations work, and percentages in our summary lesson, which will be live in October. Okay, thanks a lot for listening.